Here's a video on Move the Monster. This is just another worksheet of transformations using this little made-up graph, which we're calling the monster. On this worksheet, we are going to be doing domain and range in set builder and interval notation. Set builder is this one on the left, and interval notation is this one on the right. I would like for you to do all of the odd problems in set builder and even problems in interval notation. Okay, so I'm going to actually skip the first few examples because those are just reviewing what we did in the previous video and notes. But just a reminder that we'll always do the left and right, or the adding and subtracting from x first, then multiplying the x, which will give us a horizontal stretch or compression, depending on if it makes it bigger or smaller in the x's. Then multiplying y's, which will give us a vertical stretch or compression, and then last, up and down, which is adding or subtracting from the y values. So let's go ahead and skip down to number 5. And again, on this video, I've already put these little gray graphs on there just so you can see where the graph used to be, so we don't have to switch back and forth. But let's take a look at what different transformations are happening here. So we see that there is multiplication in the front and then addition and subtraction in the back. So there's nothing inside the parentheses with the x value, so that means the transformations that we're doing are only going to be vertical transformations. So we can skip left and right in horizontal stretch or compression and go straight to the next step, which is vertical stretch or compression. So right here we're going to be multiplying all of the y values by -2 first, and then we'll move them up 4. So let's write down what the transformation is. So we're multiplying the y values by -2. That's actually going to do two things at once. Multiplying a y value by a negative number is going to reflect it over the y-axis. So we're going to reflect over the y-axis, and then multiplying by the 2 is going to stretch. It's going to make these y values bigger. So we're going to do a vertical stretch by a factor of, we're multiplying by 2, and then the +4 means we'll then move up 4. So for each of these points, we won't move left or right, but we will take each value, reflect it over the y-axis, multiply it by 2, and then move it back up 4. So let's start with this one. This y value is 1. So reflect, multiply by 2, so -1 becomes -2, and then move it up 4. 1, 2, 3, 4. The next point has a y value of 3, so we reflect it over 1, 2, 3, multiply it by 2, so 4, 5, 6, and then move it back up 4. 1, 2, 3, 4. The next point has a y value of -2, so we're going to reflect it over to +2, then multiply it by 2, so 2 times 2 is 4, and then move it up 4. 1, 2, 3, 4. Oh, it's going to go off the graph a little bit, but that's okay. The next one has a y value of 0, so reflecting it across the x-axis, it's not going to move. Multiplying 0 by 2 won't change it, but we can move it up 4. 1, 2, 3, 4. The next one has a y value of -1, so reflect times 2, up 1, 2, 3, 4. The last one again has a value at y value of 0, so reflectant times 2 doesn't do anything, but we do move up 1, 2, 3, 4. And then you connect the points in the same way that you did before. And we'll curve there. So there's our graph. Okay, so for the domain, I said that we're going to do the odd problems in set builder notation. So we have the set of all x's where, so our smallest x value is 1 to -3, and we're including that point because it's a closed point, so it's less than or equal to x is less than or equal to our largest x value is 1, 2, 3. So there's our domain. And then for the range, set of all y values where our smallest y value is -2. It's a closed point, so we'll make it less than or equal to y, less than or equal to our highest y value is 1, 2, 3, 4, 5, 6, 7. And this one just went off the screen at 8. Or not the screen, the graph. Okay, so there's the set builder notation for number 5. Let's go ahead and take a look at number 6 together as well. And here we have plus 2 and minus 1. We always start inside the parentheses. So here I have plus 2, and that's a left or right movement, so that's the first thing I'm going to do. So remember, anything inside the parentheses, you're doing the opposite of what it looks like. So this plus 2 means that we're actually going to be moving it to the left 2. So even though it says plus 2, we're actually kind of subtracting 2 on the graph. So we're going to do left 2. Okay, we don't have anything to multiply by x except 1. We don't have to multiply anything by y. There's just an implied 1 there. But we do have to do this one right here. That minus 1 means we're going to go down 1. So for each of these points, we're going to go left 2, down 1. So left 2, down 1, left 2, down 1, left 2, down 1, 1, 2, 1, 1, 2, 1, and then 1, 2, 1. And connect. Okay, so the graph is now here in green. For the domain and range, because this is an even problem, we're going to do it in interval notation. So let's see, our smallest x value is 1, 2, 3, 4, 5, negative 5. We include that because it's a closed point, so we use the square brackets, comma. Our largest x value is positive 1, close square brackets. For the range, our smallest y value is negative 1, 2, 3. We're including that point with a square bracket, and then the highest is positive 2, square bracket. All right, so let's look at one more example together, number 8. And I picked this one because you probably weren't looking forward to doing it yourself, but because it has the most transformations to do in one problem. Okay, so the first thing we want to do is look inside the parentheses and see if there's anything that I need to do there first, and there is. So I've got this minus 3, so that means on the graph we're actually going to be adding 3 to each of the x values, so we're going to move to the right 3 first. Okay, there's nothing else to look at inside the parentheses, so I move to the front. So I've got a negative 1/2, that means that 2 things are going to be happening there. The y values are being multiplied by a negative, so that means they're going to reflect over the x-axis. And then we're also multiplying by that 1/2, so that means we have a vertical, multiplying the y values by 1/2 makes them smaller. So vertical compression by a factor of, we're multiplying by 1/2. And then finally, this plus 2 will go up 2. So we have a lot of things to keep track of, so make sure you're very careful whenever you're doing these. Okay, so on my first point, so each time we're going to go right 3, reflect over the x-axis, multiply the y by 1/2, and then up 2. Here we go. So 1, 2, 3, reflect times 1/2, up 1, 2. And I really suggest that you just try to do this one maybe on your paper first and then compare it to mine and see how you did, because this could be a little overwhelming. So at this point, moving to the right, 1, 2, 3, reflected over the x-axis. Negative 3 times 1/2 is negative 1.5, and then up 1, 2. The next point we have is right here. Its y value is at negative 2, in case you can't see. So we're going to go to the right, 1, 2, 3, reflect over the x-axis, multiply the y values by 1/2, and then move up 2. The next point, to the right, 1, 2, 3, reflect over the x-axis, won't change anything, multiplying by 1/2 won't change anything, but we can go up 2. This next point, right, 1, 2, 3, reflect, times 1/2, up 2. And finally, the last point, to the right, 1, 2, 3, reflect, and multiplying by 1/2 won't change this 0, but we do go up 1, 2. So our graph now looks like, and then the little bump, there we go. Okay, so you have to be really careful with these. It's easy to get lost, but if you have your previous graph lightly sketched on there, it makes it easier to figure out where to go. Okay, so for the domain, this is an even problem, so we're going to use interval notation. Our smallest x value is 0, and our largest is 1, 2, 3, 4, 5, 6. And we include both of these, so we're going to have square brackets. For the range, our smallest y value is right here at 1/2. So 1/2. Our largest y value is 3. And we include both of these because they are square closed points, so we're going to use square brackets. Okay, well that is it. You're going to have the rest of the problems to do on your own. Good luck, and let me know if you have any questions. Hope you're having a great day. Bye.